So here's the homework problem where we're trying to find the tension in these three cables. And the equations are given here in matrix forms. It's what we're really trying to find out is how far away can we attach this third cable along the y-axis here. How does that affect the tensions? Well, the first part of the problem was to write a function. And so we start out with the word function. What we want to come out of this is the factor of safety, and we'll call this cable 3, for example, and the argument of that is going to be that distance d. Okay, I have to find the length of the cable, which is just the square root of 10 squared plus d squared. And now let's enter the coefficient matrix, which was given as 0.348 minus 0.557 and 0 on the first row, then minus 0.348 minus 0.239 d over L, that's the second row, and then 0.870, 0.796, and finally 10 over L. Okay, our matrix of constants is 0, 0, and 1000, column matrix. And now to solve for the tensions, simply A backslash C, capital A there. And I'm going to leave the semicolon off for a moment so we can check our answers. Okay, so we take the maximum value and have 1500 divided by that maximum value gives us the factor of safety. So 1500 divided by the max of the tension values, and that is the factor of safety. Okay, let's go ahead and save that. Of course, we'll save it with the same name that's in here, cable 3. And now from the command line, let's try that for d equals 2. And you can see the answers come up with what we checked them against in Excel. So 658 pounds is the maximum tension. 1500 divided by that gives us a factor of safety of like 2.28. Okay, so now that we know that works, I'm going to put a semicolon right here because we don't need that every time. But now I'm going to make a new script because we want to do this in a loop now. And so we're going to make a for loop, and we'll make a counter. We'll call it k. We want it to go from 0 in a length by increments of 0.1 and to a final value of 20. Okay, now I need indices for the distances and factors of safety I'm going to store in an array. So let's make another variable here. We'll call it m. That's going to be the index of our matrices. So the first thing in the for loop is let's make d of m simply equal to the value of k. So the first value will be equal to 0. The next value, d of 2, is going to be equal to 0.1, etc. Okay, now for the factor of safety, we're simply going to use the function. So we evaluate the function at this value of d of m. And so what we're doing is we're creating arrays of the distance and the factor of safety. And we want to then advance m, whoops, we'll advance m by 1 every time we go through this. And that's the end of that. And so now all we have to do is plot. And on the horizontal axis, we want the independent variable d, and then the factor of safety on the other axis. Okay, let's try to run this. It's going to prompt us for a name, and we'll call it Cable 3 plot. And there's our plot. You notice there's a point up here. We'll talk about that in a moment. And we can actually see that looks like about 5.7, 5.8. We come up with the maximum value of the factor of safety, 3.34. Now, if I wanted to actually print that value to the screen, what we can do is use the max command, because, pull this over a little bit, you notice we've got the arrays of D and factor of safety stored now. And so if I just type in max of the factor of safety, then we get that value of excuse me, 3.345. But if I want to know the D that corresponds with that, what I can do is use the max command again. But let's do this. Let's assign fs max, and again I'll just call it n for a moment, equals max of the factor of safety. So what I get out of that, of course, is the 3.34 again, and in this 58, that is the index of the array. And so if I type in d of 58, or just d of n, it'll give me the distance that corresponds with the max, and in this case it is 5.7 to the nearest tenth. And so that's how that works. Now, I will show you over on Excel here. If I were to plot the tensions in all three of the cables, you can see why there's a break there at that 5.7 or so excuse me, length. So at the beginning, when we hang it at 0, then cable 3 is hanging straight up and down, and it ends up taking all of the force. As we move D further along, you can see there gets to be more load sharing between the three cables. And it's at this point where cable 1 becomes critical. And so you can see that, we're plotting tensions here. The maximum factor of safety is going to be at this point where the maximum tension is at its lowest point, if you want to look at it that way. And just finish that up. Also here in Excel, you can see here's the equation set up for a distance of 2, gives you a factor of 2.28. We've played with solver a little bit, and let me show you how we can find the optimum length here. I'm going to go data solver, and so what I've set up is to try to maximize the factor of safety by changing D. And click solve. And you can see that, with the MATLAB plot, we were getting it to the nearest tenth. And if we wanted a little closer, so it's about 5 3/4 feet, gives us this factor of safety of 3.35.